Okay, so what we have here are two big 5 kilowatt AM.
5,000 watt amplitude modulation broadcast transmitters.
Okay, and so there's two of these. There's this whole unit here, then there's this whole unit here. And recently everybody probably has seen some of the videos of the audio rack that we're assembling up in Spokane. And would you say that's essentially maybe a lower power version of pretty much what?
Well, that's what we're building, is higher frequency, lower power, more tactical version of what these things are.
And so these would have been found inside of a radio station, an AM?
Yeah, these were some town for 20 years were on the air in some local AM radio station. Mm-hmm. So they're both working units, or allegedly they're working units.
Mm-hmm. And what is the ultimate goal of these with the right power setup and everything?
Well, one objective is to transmit into the earth in the medium frequency band, around 500 kilocycles.
Okay.
And to facilitate that, one of the advantages of this particular structure here is it has two big tanks filled with water buried in the ground outside, a 15,000 gallon and a 35,000 gallon, and that will be the electrode for transmitting tellurically in the medium frequency band. Mm-hmm. And then the other purpose is the cosmic induction generator. So the one that's being constructed right now is a 1/5 scale of this unit here and whatever transformer, an RF transformer would go with it.
The one we're making up in Spokane.
Right.
So this one we kind of have opened here with the panels. I'm going to kind of explain what we're looking at.
Okay, well, most of the tubes are removed, but this is the this is basically the radio frequency rack is here. So we can't see much of it from this side. So these are the tuning controls to set it to where the amplifiers are tuned to whatever frequency it's assigned to. I think as these came, one is like 530 and then the other one's like 950 or something like that, but we'll have to use different frequencies for this stuff here. Okay. So these would be basically the amplifier tubes to take it from the oscillator. One of them is probably the oscillator. Here's what the meters are showing here. Okay, so one's an oscillator, and then the buffer, that would probably be one of these here. And that's the voltage supplied to their plates. And this is like the high voltage shutoff relay here. And so what this does is this takes the tower, disconnects the broadcast tower from the transmitter. That's the disconnect switch. Looks like it's been kind of munged up a bit. So let's see what kind of adventures will be ahead trying to get any of this stuff working. Loose hardware floating around and wires people changed, and that's always the worst part, is where the monkey fingers get in there and just make a mess out of the inside, and then you got to put it back to normal. So this is the audio frequency side.
So this would be like the audio rack we're building, yeah. And that's the RF rack.
Yeah, basically everything in here will correspond exactly to a piece that's in what we built. So this is the hard part. Very expensive and hard to find. This is the modulation transformer. So basically all it really is a big audio output transformer.
Put this on the spark.
And this one is oil filled, which is very advantageous because they really develop some nasty transients and tend to burn out. So this is a 3 kilowatt transformer. In other words, this thing will deliver 3,000 watts of audio of any waveform, frequency, or whatever within the spectrum these were designed for, which is usually like from about 100 cycles to 8,000. So here's the modulation choke, I believe. take a look at the other side. See what the, yeah, that's the modulation choke. It's a modulation transformer.
Open the back panels.
Yeah, and then the big tubes, the big iMac tubes sat up here, 4-1000As. They're some real behemoths. They're pumpkin-sized tubes. So, and then the meters for that will be here. So this is the voltage coming in from the power line, and then these are the two modulator tubes. And then this is the screen grid of the modulator tubes, voltage on them. And then this is the radio frequency side. So this thing runs about 7,000 volts. 6,000, probably because of these tubes here. I'd say about 6,000 volts on the plates.
This is the back of the RF.
Yeah, so
We have here.
this is where the RF power tube plugs in. It's a pretty good size. I've got a coffee can size radiator on it. Tuning coil. So, and that's all the antenna circuitry. And then that's the output to the tower, is that white feed-through insulator right down there. That's where it goes out.
Does it get hot in here? Looks like there's an air duct for a blower or something.
This thing has to be forced air cooled. All these, even the glass ones in the modulator cabinet, they are also required to be forced air cooled.
Is that a vacuum capacitor?
Yeah.
So this is the back of the audio side.
Yeah, and a lot of the low voltage stuff. So we can already see a really bad sign here. These are the things that you don't like to have see, is somebody had some ideas. So now we don't know what those ideas mean, and these old PCB capacitors and stuff, they don't really so. And then this is really, when you see this, you know you've had.
I'll get a clip.
That means the monkey's fingers have been in here, and it's anyone's guess as to what kind of concoction this thing has been turned into. I liked it better when I used to get paid like $50 or $100 an hour to do this stuff. It gives it a little more inspiration, providing you start right after morning coffee, not a minute later. Okay, so this is the power supply. Where is the high voltage choke?
Blower there. We have all these up here.
Yeah. Now here's one thing that's crazy about the design in this thing is somebody mounted all the transformers upside down, which is fine as far as making more space, but then the thing is you know, a little lizard ends up, or a cockroach ends up dancing around in here and lands on those terminals, you get the big fry. Or something drops on them, so not best of ideas, but...
So then you have to debug it?
What's that?
You have to debug it?
Debug it, yeah. Makes it easier though when you have to measure voltage. Yeah, I can't, I'm trying to figure out where the modulation choke is. There's one choke I can't account for in here. I guess it doesn't have one. I'll leave it. That's the transformer. Might not have a power supply choke. Now there's some problems here that are going to have to be addressed later down the line. This is not really a good design here. Is the power coming in is too close to the high voltage. It's unacceptable clearance. So if something gets in there and that flashes over, then the high voltage side of this will backfeed into the low voltage power line, and that can cause a lot of complications with other things that are running on the same power that this is running on. So I think what my plan is, because these things are in a fixed location, is to completely remove this, change all this around, and then in the power supply panel, that's where these will be, is in the power supply panel, and then just send the high voltage straight over here.
So for the cosmic induction generator experiments, for example, do you need both units, or you just need one, or
just one?
So just one.
Yeah. So whichever one is tuned for the higher frequency would be the one. So the frequency you can kind of tell from the size of these coils. And good luck finding any of this stuff anymore. You can't just change coils like you used to. You know, you just don't call up this company and say I need a coil for $950. So let's see what the coil looks like in the other one. Oh, this one's got a lot more turns on it, much bigger capacitor. So this is the 500 kilocycle one, and that's the 900 kilocycle one.
This more smaller one. Yeah, so this one has a lot more turns on it here compared
this has got to be the modulation
to this one here.
It's a 9-phase rectifier, so it probably doesn't need the choke. You can cheat on the choke when you go that many phases. The only time you really need the choke is when you don't have polyphase power, because power pulsates. But in polyphase it doesn't. It's the more phases you have, the smoother it is. Well, that's what this is. Class C, plate modulated. Yeah, so I want to get those damn things out of here.
Okay, so these are the 5,000 watt AM transmitters. We already went over kind of the insides of it, how they're kind of put together, with the one side's kind of its own audio rack, the other side is kind of the RF rack, and that's essentially what we're building up in Spokane, which is a smaller power unit. And so for the whole cosmic induction generator project, can you paint like a visual, kind of like a block diagram of how this fits into the whole system, what's needed as far as power, the Tesla coil, the bulbs and all that, and how you kind of foresee this, you know, playing out?
So the first complication here is the 3-phase power requirement, because right now, even though there's, as I showed in what I've talked about earlier, we do have something resembling a 3-phase power connection here. Whether the rectifiers will like it or not is yet to be seen, but we have to get the power into the building here. And the added difficulty of getting the power into the building is we can't have any of these experiments radiating out in this double Y power system in town here and lighting the whole town up with RF and creating interference and broadcasting while we're doing experiments. So one of the big expenses is the isolation transformer to go between the power company and the electrical system here in the building. So there has to be a transformer bank to segregate the outside world from the inside world, because I think I talked about when I had these things opened up, the clearances in the high voltage power supply are highly inappropriate for the voltages involved. And that endangers the low voltage side of the line. If high voltage flashes over to the low voltage, then it's going to go running through transformer windings and equipment that's plugged in and what have you. Or if it's an ungrounded system, which I prefer, it's going to charge the whole system up to the plate voltage. So what I plan to do, which is not the best thing in the world, but to pull the rectifiers out completely and put them in the power room. That way, then, rather than having a three-phase 100 amp, all the copper involved in a three-phase 100 amp coming from where the power comes in the building on the exact opposite side over to here, all that pipe and wire will be reduced greatly in size. If all it has to power is the tube filaments and the auxiliary power supplies, and instead put the high voltage rectifiers in the power room, and then basically all that's needed is a very well insulated 14 gauge wire in the conduit to supply the high voltage plate power to the tubes, which the total is probably going to be maybe 4 or 5 amps. So 14 gauge wire's got 15 amp capability, so we'll have to get some high voltage 14 gauge wire and then rebuild the rectifiers right and put them in an environment where there is no possible way there can be a cross connect between the high voltage and the low voltage side. So then a RF output lead has to be developed. The coax and the coax connectors for a 5 kW AM transmitter is very costly. One route out is to use strip line, because impedance matching is not a big consideration here because it's just a short distance. So over here, move the camera over here, this stuff that's in front of these windows here and all that basically all gets cleared out along with these test racks, and this is where the actual Tesla transformer will go. So the idea is there'll be a control panel on the other side of the windows, and that will control the frequency and the amplitude and power and what have you. And then out here will be a special bench that will have the 5,000 watt Tesla transformer, push-pull Tesla transformer arrangement for the cosmic induction generator. The walls will all be filled with chicken wire as a shield to separate the electrostatic component, but allow the normal electromagnetic component of the siliphones and what have you to go through. But the electrostatic field from the Tesla transformers will not be able to get through the chicken wire, but they won't disturb the normal electromagnetic propagation in the building. And that will be grounded to our ground system. And that would basically comprise the cosmic induction generator. But this area in general is designated to be left open for any possible experiments with these AM radio transmitters. And one of them is the high-speed electrostatic motor or generator, what I call the Trump motor, because it was Donald Trump's uncle that wrote an excellent paper on how to put an electrostatic motor together with no coils or magnets, or conversely it'd be a generator. So because we have 2 AM radio transmitters, we have 2 AM radio transmitter modulators, which are capable of putting out the frequencies necessary to turn one of these things at the insane speeds of 100,000 to 200,000 RPM. So in order to do that properly, you have to have a polyphase system. So one modulator will be 90 degrees out of phase with the other modulator. Yeah, so they got 2 6,000 volt audio frequency phases, 90 degrees out of phase. Then that gets stepped up with a network or a transformer to 60 to 100,000 volts for the ultra high speed electrostatic motor. So these transmitters basically are Here they're more of a laboratory item than just a simple radio transmitter. Obviously they'll do a number of things.
High voltage power supply.
Yeah. Frequency generators, high power frequency generators, and then some kind of transmission line has to be developed to take the RF and bring it over to where it's going to be utilized.
Okay.
So that's usually a very expensive project.
Okay,
But I think I've got some simpler methods of going about it, but nevertheless, there still has to be a line that goes to, they have to have a dummy load by law to tune these things up and what have you. So I have 7,500 watt incandescent light bulb bank, and that goes down in the storage pit underneath the floor of the room here. That'll help keep all that humidity and what have you down in there. So there has to be a cable, high frequency cable to that too. So the high frequency wiring, even though it has less copper, can get a lot more expensive than the power frequency wiring because of coax connectors. And so this isn't just a simple little job.
Right. So cosmic induction generator and the rotary electrostatic, you know, motor slash generator project.
Yeah.
And then for the cosmic induction generator, like the output for the CIG project, about like what size would the coil, the Tesla coil, look for that?
That big around and about that long. Each phase, that would be the extra coil.
And then
And the one that you're putting together now it'll be 5 times bigger than the one that you're putting together now.
So the type of bulb, what's the special properties needed for the bulb to show like their galaxy
You can't have any
formations?
metal in it, which that's why the burned out ones work best, because the metal inside of them had been blown away. And you have to have the right gas pressure and the right metal ions to form the plasma formations.
And David could make one.
Yeah,
So
yeah.
You can
There'd be some experimenting, you know, to find
Yeah.
out what the optimum.
right.
There's a lot of experimenting involved with this. So it's the same thing with the Tesla transformers. That's unlike the RF and the audio frequency equipment. That's not just do it the standard way deal. In that case, it's got to be, there's a lot of tuning and experimenting. And that's going to take just as much time as putting all the rest of the stuff together. So, but a lot of experience has been gained in that regard, so it's not going to be a completely blind operation.